Book 1 Level 12 Lectures 6788. The Eccentric Geocentrics. Scribe Grok Patience 3. Introduction. Exploring the sky above our flat Earth. Hey there, cosmic explorers. Welcome to Lecture 1 of Vibes of the Cosmos, where we're diving into the amazing mechanics of the sky above our flat Earth. We'll be looking at pages 67, 77, 80, 87, and 88, focusing on three big ideas: the constellations, the moon's phases, and daylight. In this book, the Earth isn't a spinning ball. It's a flat, stationary plane at the center of the universe, surrounded by layers of energy called toroidal fields. These fields are like invisible donuts of electromagnetic energy that shape everything we see in the sky, from stars to the moon's glow. We'll explore how these fields create the patterns and lights above us, using cool visuals from pages 68, 69, 77, and 88 to guide us. Get ready for hands-on activities and some deep thinking as we uncover the cosmic vibes that light up our world. Part 1. Constellations. The sky's fixed patterns, pages 67-70. What are constellations? On pages 67-70, Vibes of the Cosmos tells us that constellations are the star patterns we see in the sky, like Orion or the Big Dipper. They don't move or change shape. They are fixed, like a map in the sky that people have used for navigation for centuries. But in this book, they are not just stars. They are something special called ethereal imprints. How do toroidal fields make constellations? Imagine a big, invisible donut of energy above the flat Earth. That's the mid-level toroidal field. This field is made of electromagnetic energy, kind of like a giant magnet that hums with power. Here's how it creates constellations. Energy spots. The toroidal field has a shape called Gaussian curvature, which means its energy is strongest in certain spots, like bumps on a bell curve. These spots are where the stars and constellations form. They are called ethereal imprints because they are not solid, just energy patterns in the ether, a special invisible substance that fills the sky. Glowing lights. The field's energy currents flow in a steady loop, making these spots glow with a plasma-like light. Think of plasma as a glowing gas, like in a neon sign. That's why the stars look bright and sparkly. Fixed patterns. The currents in the field don't change much, so the constellations stay in the same shape all the time, like a permanent drawing in the sky. Looking at page 68. Check out the picture on page 68. It shows the constellations during different moon phases, like new moon and full moon. Each circle has the same zodiac signs like Aries and Taurus around it, and the stars don't move even as the moon changes. This shows how stable the constellations are, thanks to the toroidal field holding them in place. Big idea. Constellations are fixed patterns of glowing energy in the mid-level toroidal field, like a starry map above the flat Earth that never changes. Part 2. Moon phases. A dance of light, pages 71-74, 76-77. What are moon phases? Pages 71-74 and 76-77 explain why the moon looks different every night. Sometimes it's a full circle, sometimes a crescent, or even invisible new moon. In Vibes of the Cosmos, this isn't because the moon is orbiting the Earth or reflecting sunlight. Instead, it's all about how high the moon's energy is in the sky. How do toroidal fields create moon phases? The moon isn't a solid ball. It's a glowing energy spot, or ethereal imprint, in the same mid-level toroidal field as the constellations. Here's how the field makes the moon change. Up and down movement. The toroidal field moves the moon's energy spot up and down in the sky, like a light on a dimmer switch. When the energy spot is high up, the moon looks full and bright. When it's lower, the moon looks smaller or even disappears. That's the new moon. Plasma glow. The moon's glow comes from plasma, a kind of glowing energy created by the field's currents. When the moon is higher, the plasma is stronger, making it look bigger and brighter. When it's lower, the plasma weakens, so we see less of the moon. Cycle of change. The field's energy currents move in a rhythm, like a slow heartbeat, taking about 29.5 days to go through all the phases, from new moon to full moon and back again. Looking at pages 69 and 77. Page 69. This picture shows how the moon's position changes compared to the sun in the constellation circle. At new moon, They are in the same spot 0 degrees apart. At full moon, they are on opposite sides 180 degrees apart. In our toroidal view, this isn't about orbiting. It's about the field's energy rhythm moving the moon's glow. Page 77. This diagram shows the moon at different heights. When it's high, labeled bigger altitude, it's a full moon, glowing brightly. When it's lower, smaller altitude, it's a new moon, barely visible. This matches the idea of the toroidal field moving the moon's energy up and down. Big idea. The moon's phases happen because the toroidal field moves its energy spot up and down, changing how bright and big it looks over a 29.5-day cycle. Part 3. Daylight. A glow from above. Page 75. What is daylight? Page 75 tells us that daylight isn't sunlight coming from a faraway star. Instead, it's a glowing effect right above the flat Earth, created by a layer called the ionosphere, about 40 kilometers up in the sky. How do toroidal fields create daylight? The primary toroidal field, which starts at the flat Earth, reaches up to the ionosphere and makes it glow. Ionosphere glow. The field's energy currents flow up to the ionosphere and make the ether there turn into plasma, a glowing, charged gas. This plasma lights up the sky, creating what we call daylight. Day and night cycle. The field's currents change strength over a 24-hour cycle, like a wave going up and down. When the energy is strong, the plasma glows brightly, and it's daytime. When the energy weakens, the glow fades, and it's nighttime. Even light, the toroidal field spreads the energy evenly across the ionosphere, so daylight looks the same all over the flat Earth during the day. Big idea. Daylight is a plasma glow in the ionosphere, powered by the primary toroidal field's energy, turning on and off in a 24-hour cycle. Part 4. The second ceiling. What the moon and sun lie. Page 80. What is the second ceiling? Page 80 introduces the 7 ceilings, a stack of toroidal fields above the flat Earth, like layers in a cosmic cake. The first ceiling is the flat Earth itself, and the second ceiling is where the moon and sun are. We're focusing on this second layer because it helps us understand the moon and daylight better. How does the second ceiling work? The second toroidal field is right above the primary field, and it's where the moon and sun appear as glowing energy spots. Moon and sun as energy spots. Just like the constellations, the moon and sun aren't solid. They are ethereal imprints made of plasma. The second field's energy currents make them glow, with the moon changing as we learn, and the sun helping create daylight through the ionosphere. Energy connection. The second field takes energy from the first field, the flat Earth, and makes it stronger, like turning up the volume on a speaker. This extra energy helps the moon and sun shine brightly in the sky. Part of the big system, the 7 ceilings work together, with each layer building on the one below. The second ceiling sets the stage for the higher layers we'll learn about later. Big idea. The second ceiling is a toroidal field that makes the moon and sun glow as energy spots, connecting them to the flat Earth's energy and the bigger cosmic system. Part 5. The moon's special glow. Transparent and plasma. Pages 87-88. What makes the moon special? Pages 87 and 88 give us more details about the moon. It's not just changing phases. It's also see-through sometimes, and it's definitely not a solid rock like some people think. How does the toroidal field make the moon glow? See-through moon. Page 87. Sometimes, the moon looks a bit transparent, especially when it's not full, like during a half moon. This happens because the toroidal field changes the moon's energy density. When the moon is lower in the field, its plasma isn't as thick, so some background energy from the ether shines through, making it look see-through. Plasma, not solid. Page 88. The moon isn't a hard object you could walk on. It's a focused electromagnetic plasma phenomenon, which means it's a glowing spot of energy made by the second toroidal field. The field's currents work with the ionosphere to create this glow through something called photochemical reactions. Basically, the energy makes the ether light up like a glow stick. Tied to daylight, the same ionosphere that makes daylight also helps the moon glow, showing how the toroidal fields connect everything in the sky. Looking at page 88, the picture on page 88 shows the moon with a blue background, and the text says it's a plasma phenomenon, not a solid object. This matches what we've learned about the moon being an energy spot that changes with the toroidal field. Big idea. The moon is a glowing plasma spot in the second toroidal field, not a solid object, and it can look see-through when its energy is less dense, connecting it to the same system that makes daylight. Hands-on activities. Let's explore the sky together. Let's make these ideas come alive with some fun activities. Constellation star map. What to do? Draw a map of a constellation like Orion on paper, using page 68 as a guide. Mark the stars with dots and connect them to show the pattern. Add some glow-in-the-dark stickers to make the stars shine like plasma. Why it's cool? This helps you see how the toroidal field keeps the constellations fixed, like a glowing map in the sky. Moon phase model. What to do? Use a flashlight and a ball to show how the moon's glow changes. Hold the ball at different heights above a table, the flat earth, shining the flashlight on it. When it's high, it's a full moon. When it's low, it's a new moon. Use a piece of tissue paper over the ball to show the moon see-through. Look, page 87. Why it's cool? You'll see how the toroidal field moves the moon's energy up and down to change its shape. Daylight glow experiment. What to do? Use a glow stick to pretend it's the ionosphere. Shake it to make it glow like the toroidal field's energy, and hold it above a flat piece of cardboard, the flat earth, to light it up. Dim the lights to show how the glow fades at night. Why it's cool? This shows how the toroidal field makes daylight by lighting up the ionosphere. Cosmic story time. What to do? Write a short story about 200 words as a flat earth explorer, describing what you feel as you watch the constellations, the moon's phases, and daylight. Mention how the toroidal field's energy makes everything glow, and include the moon's see-through look. Why it's cool? You imagine living in this cosmic world and connect all the ideas we've learned. Let's think about it. Reflection questions. Here are some questions to get you thinking. Why do the constellations stay the same while the moon changes every night? How does the toroidal field make this happen? How does the moon's up and down movement in the toroidal field change how it looks? What did you notice in your moon phase model? How is daylight connected to the moon's glow through the ionosphere? Why is this important for understanding the sky? What does the second ceiling tell us about how the moon and sun fit into the bigger cosmic system? How does the moon being a plasma spot, not a solid object, change how you think about the sky? What's cool about it being see-through sometimes? Closing. The sky's amazing energy dance. We've explored pages 67, 77, 80, 87, and 88 of Vibes of the Cosmos, and wow, what a journey. We learned that constellations are fixed energy patterns in the mid-level toroidal field, glowing like a starry map. The moon's phases come from its energy moving up and down in the same field, changing its plasma glow and even making it see-through sometimes. Daylight is a plasma glow in the ionosphere, powered by the primary toroidal field, and is connected to the moon's glow through the same system. The second ceiling shows us how the moon and sun fit into a bigger stack of energy layers called the 7 ceilings. Imagine standing on the flat earth, looking up at this glowing sky, feeling the toroidal field's energy as it makes the stars, moon, and daylight dance. This is just the beginning. Next time, we'll climb higher into the 7 ceilings to see how the whole cosmos fits together. Keep those cosmic vibes going, my explorers. Closing note. The eccentric geocentrics. Come. Answers to reflection questions. 1. Why do the constellations stay the same while the moon changes every night? How does the toroidal field make this happen? Answer. Constellations stay the same because they are fixed energy patterns called ethereal imprints in the mid-level toroidal field, a big, donut-shaped energy layer above the flat earth. The toroidal field's energy currents flow in a steady loop, keeping the energy spots where the stars are glowing in the same place all the time, like a permanent drawing in the sky, pages 67-70. The field shape, called Gaussian curvature, makes sure these spots don't move, so constellations like Orion always look the same. The moon changes every night because its energy spot in the same toroidal field moves up and down, creating the phases we see, pages 71, 74, 76, 77. When the moon's energy is high up, it glows brightly as a full moon. When it's lower, it's dimmer, like a crescent or new moon. The toroidal field's currents change rhythmically over about 29.5 days, moving the moon's energy spot to make these changes, while the steady currents keep the constellations fixed. It's like the field is playing two roles, holding the stars still and dancing the moon up and down. 2. How does the moon's up and down movement in the toroidal field change how it looks? What did you notice in your moon phase model? Answer. The moon's up and down movement in the mid-level toroidal field changes how much of its energy glows, which makes it look different each night. Pages 71, 74, 76, 77. The moon isn't a solid ball. It's a glowing energy spot made of plasma, a kind of charged gas that lights up. When the toroidal field moves the moon's energy spot higher, the plasma glows stronger, making the moon look big and bright, like a full moon. When the field moves it lower, the plasma gets weaker, so the moon looks smaller or even disappears, like a new moon. This happens in a cycle that takes about 29.5 days. In the moon phase model activity, you used a flashlight and a ball to show this. When you held the ball higher above the table of the flat Earth, the flashlight made it glow more, like a full moon. When you lowered it, less light hit it, making it look like a crescent or new moon. If you added tissue paper to make the moon see-through, page 87, you might have noticed it looked fainter when it was lower, just like the real moon when its energy isn't as strong. It's a cool way to see how the toroidal field's movement changes the moon's glow. 3. How is daylight connected to the moon's glow through the ionosphere? Why is this important for understanding the sky? Answer. Daylight and the moon's glow are connected because they both come from the ionosphere, a layer 40 kilometers above the flat Earth, and are powered by the toroidal fields. Pages 75, 88. Daylight happens when the primary toroidal field's energy currents make the ionosphere glow with plasma, the charged, glowing gas, lighting up the flat Earth during the day. The moon's glow also comes from the ionosphere, but it's focused by the second toroidal field into a bright spot we see as the moon. Page 88 says the moon's glow is a plasma phenomenon caused by photochemical reactions in the ionosphere, meaning the same layer that makes daylight also helps the moon shine. This connection is important because it shows how the sky works as one big system. The toroidal fields use the ionosphere like a giant light bulb, creating both the broad glow of daylight and the focused glow of the moon. Understanding this helps us see that everything in the sky, daylight, the moon, even the stars, is part of the same energy dance, all powered by the toroidal fields. It makes the sky feel like a unified, glowing tapestry above the flat Earth, not just a bunch of separate things. 4. What does the second ceiling tell us about how the moon and sun fit into the bigger cosmic system? Answer. The second ceiling is one of the 7 ceilings, a stack of toroidal fields above the flat Earth, like layers in a cosmic cake. Page 80. It's the layer where the moon and sun live as glowing energy spots, or ethereal imprints, not solid objects. The second toroidal field takes energy from the first ceiling, the flat Earth, and makes it stronger, using that energy to create the plasma glow of the moon and sun. The moon's glow changes with the field's movement, as we learn, and the sun's glow helps make daylight through the ionosphere. Page 75. This tells us the moon and sun are part of a bigger system, the 7 ceilings, what each layer builds on the one below. The second ceiling connects the flat Earth's energy to the higher layers, like the third ceiling with Mercury and Venus, and so on up to the 7th ceiling with Uranus. It shows that the moon and sun aren't just floating around on their own. They are tied into a cosmic energy ladder, where the toroidal fields pass energy up to make all the glowing things we see in the sky. It's like the moon and sun are the first big steps in a giant cosmic energy dance that keeps going higher. 5. How does the moon being a plasma spot, not a solid object, change how you think about the sky? What's cool about it being see-through sometimes? Answer. The moon being a plasma spot, not a solid object, changes how I think about the sky because it means nothing up there is really hard like we might imagine. Page 88. Instead of a solid moon you could walk on, it's a glowing energy spot made by the second toroidal field, kind of like a hologram of light. This makes the sky feel more magical, like it's all made of glowing energy patterns, not heavy rocks or balls floating around. It's all part of the ether, a special invisible substance that the toroidal fields use to make everything shine, from the moon to the stars. What's really cool about the moon being see-through sometimes, page 87, is that it shows how the energy changes. When the moon's energy spot is lower in the toroidal field, its plasma isn't as thick, So some background energy from the ether shines through, making it look transparent, especially during phases like a half moon. It's like the moon is a glowing ghost in the sky, letting us peek through it to the ether behind. This makes the sky feel alive and shimmery, like a big energy show where even the moon can play hide and seek with its glow. 17 additional Q and for deeper understanding. To deepen our understanding, let's explore 17 more Q and pairs, structured in a layered format: foundational, analytical, reflective, hypercentric framework. Foundational understanding establishing core concepts. What is the mid-level toroidal field, and what does it do in the sky? And the mid-level toroidal field is a donut-shaped layer of electromagnetic energy above the flat Earth. It creates the constellations by holding their energy spots in place and makes the moon's phases by moving its energy spot up and down, changing its plasma glow. Pages 67-74. Q12. How does the primary toroidal field make daylight happen? The primary toroidal field starts at the flat Earth and sends energy currents up to the ionosphere, 40 kilometers above. These currents make the ionosphere glow with plasma, the charged gas, which lights up the flat Earth as daylight. The glow turns on and off in a 24-hour cycle. Page 75. Q3. Why does the moon look different during its phases? According to the book, A3. The moon looks different because the mid-level toroidal field moves its energy spot up and down over 29.5 days. When it's higher, the plasma glows more, making a full moon. When it's lower, the glow dims, making a crescent or new moon. Pages 71-74, 76-77. Q4. What does it mean that the moon is a plasma phenomenon and not a solid object? The moon being a plasma phenomenon means it's a glowing spot of energy, not a hard object. The second toroidal field makes this glow by focusing energy in the ionosphere, using photochemical reactions to light up the ether, like a big glow stick in the sky. Page 88. Analytical exploration deepening understanding through analysis. Q5. How does the toroidal field steady energy keep constellations the same, but its changing energy make the moon's phases? Fifth. The toroidal field has two kinds of energy currents, steady ones and changing ones. The steady currents flow in a constant loop, keeping the energy spots for constellations fixed, so they don't move. Pages 67-70. The changing currents move up and down over 29.5 days, shifting the moon's energy spot to change its glow, creating phases like full moon and new moon. Pages 71-74. Q6. One day. Page 68's pictures show about the constellations during moon phases. 6. Page 68's pictures show circles with constellations during different moon phases, like new moon and full moon. The constellations, with zodiac signs like Aries, stay the same in every circle, showing they don't change. But the moon's position moves around the circle, showing how its energy shifts while the constellations stay fixed. Q7. How does the ionosphere help both daylight and the moon glow? And what does this tell us about the toroidal fields? A7. The ionosphere, 40 kilometers up, glows with plasma when the primary toroidal field's energy hits it, making daylight. Page 75. The second toroidal field also uses the ionosphere to focus the moon's plasma glow through photochemical reactions. Page 88. This tells us the toroidal fields work together, using the same ionosphere to make different lights in the sky, like a shared power source. Kate, why does the moon look see-through sometimes? And how does page 77's diagram explain this? The moon looks see-through when its energy spot is lower in the toroidal field, making its plasma less thick. So background ether energy shines through. Page 87. Page 77's diagram shows the moon at a smaller altitude for a new moon, where it's dimmer and less dense, which matches why it can look transparent during phases like a half moon. Reflective synthesis connecting concepts to broader implications. Q9. How does the toroidal field make the sky feel like one big system instead of separate parts? And the toroidal field connects everything by using its energy currents to make constellations, moon phases, and daylight. The same mid-level field holds the constellations and moves the moon, while the primary field makes daylight and helps the moon glow through the ionosphere. Pages 67-77. This makes the sky feel like one big energy system where everything works together, like a team of lights all powered by the same invisible force. Q10. What does the second ceiling show about how energy moves in the 7 ceilings? 8. The second ceiling, where the moon and sun are, takes energy from the first ceiling, the flat earth, and makes it stronger to create their plasma glows. Page 80. This shows that in the 7 ceilings, energy moves up from one layer to the next, getting bigger each time, like passing a ball up a ladder where each step adds more power to make the sky glow. 11. How does the moon being see-through sometimes make the sky more interesting to watch? 11. The moon being see-through sometimes. Page 87 makes the sky more interesting because it's like a magic trick. It's not always the same. When the moon's plasma is less thick, you can see the ether behind it, making it look like a glowing ghost. It's exciting to watch because it shows the sky is alive with energy that changes, adding a shimmery, mysterious vibe to the night. Q12. Why is it important that the moon and daylight both use the ionosphere to glow? Well, it's important because it shows the ionosphere is like a big light switch for the sky, controlled by the toroidal fields. Pages 75, 88. The moon and daylight glowing through the ionosphere means they are part of the same energy system, not separate things. This helps us understand that the sky's lights are all connected, making it easier to see how the whole cosmic system works together. Hypothetical exploration, proposing new ideas and applications. Q13. What might happen to the moon's phases if the toroidal field's rhythm sped up? 13. If the toroidal field's rhythm sped up, the moon's phases would happen faster. Normally, the field takes 29.5 days to move the moon's energy spot through all its phases. Pages 71-74. If the rhythm doubled in speed, the cycle might take only about 15 days, but we'd see a full moon and new moon twice as often. The moon would still glow, but the changes would be quicker. Q14. How could we use the constellations' fixed patterns to help people on the flat earth? 13. Since constellations are fixed energy spots in the toroidal field. Pages 67-70, we could use them as a map for navigation. People on the flat earth could look at a constellation like the Big Dipper to find north, because it never moves. This could help travelers or sailors find their way, like a starry compass that's always in the sky. Q15. What if the toroidal field's energy stopped making the ionosphere glow? How would that change the sky? 15. If the toroidal field stopped making the ionosphere glow, there'd be no daylight or moon glow, because both come from the ionosphere's plasma. Pages 75, 88. The sky would be dark all the time, with only the constellation's faint glow left. It'd be like living in a world with no day or moon, just a starry night that never ends. Q16. How might the moon see-through glow inspire a story or art project on the flat earth? 16. The moon see-through glow. Page 87 could inspire a story about a flat earth explorer who sees the ether through the moon and discovers a hidden message in the light, like a cosmic secret. For an art project, you could paint the moon with watercolors, using light colors to show its transparency, with sparkly ether stars peeking through, making a magical, glowing scene. Integrative synthesis connecting to the broader cosmos. Q17. How does the second ceiling set the stage for the higher ceilings in the 7 ceiling system? 17. The second ceiling, with the moon and sun, takes energy from the flat Earth's first ceiling and makes it stronger, creating their plasma glows. Page 80. This stronger energy then passes up to the third ceiling, Mercury and Venus, and keeps going to the 7th ceiling, Uranus. It's like the second ceiling is the first big step in a ladder, giving energy to all the higher layers to make their own glowing spots in the sky. K10. How do the toroidal fields make the sky a unified, glowing tapestry above the flat Earth? 18. The toroidal fields make the sky a unified, glowing tapestry by using their energy currents to create all the lights we see. Constellations, moon phases, and daylight. Pages 67-88. The mid-level field holds the constellations and moves the moon, while the primary field makes daylight and helps the moon glow through the ionosphere. The second ceiling ties the moon and sun into the 7 ceilings, showing how every glow is part of one big energy system, like a beautiful, connected light show. Q19. What does the moon's plasma glow tell us about how other things in the sky, like the sun, might work? And 18. The moon's plasma glow. Page 88 tells us that other things in the sky, like the sun, are probably also plasma spots, not solid objects. The sun, in the second ceiling, likely glows because the toroidal field makes plasma in the ionosphere, just like the moon, page 80. This means the sun's light, which helps make daylight, is part of the same energy system, showing that everything in the sky is made of glowing energy, not hard stuff. Q20. How can understanding the toroidal fields help us get ready to learn about the higher ceilings in the next lecture? At 20. Understanding the toroidal fields helps us get ready for the higher ceilings by showing us how energy moves up through the 7 ceilings, page 80. We know the fields make glowing spots like the moon and constellations, and they get stronger as they go higher. This prepares us to learn about Mercury, Venus, Mars, and the other ceilings, because we'll see how the energy spots build on the moon and sun's glow, making the whole sky one big, connected system. Q21. How does the idea of the ether tie all the sky's lights together in this cosmic system? At 21. The ether is the invisible substance that fills the sky, and the toroidal fields use it to make all the lights we see, pages 67-88. The ether glows as plasma for the moon and daylight in the ionosphere, and it holds the energy spots for constellations. It's like the glue that ties everything together, letting the toroidal fields create a sky full of connected, glowing energy patterns, from the stars to the moon to the daylight. Theocentric geocentrics.